Hi there. Let's take a look at some more work with our parent graphs. And today, in this video, concentrating on some of those transformations that I mentioned, moving them left and right and up and down. Let's take a look at the line, the simple line, the parent line, y equals x. Some people call it the 45-degree line. That's possible. Some people even call it the identity line, because every ordered pair has the same x and y values, 1, 1, 2, 2, 3, 3, -1, -1, and so on. Well, with this one, if you want to move it up and down, do you remember y equals mx plus b? That b, the intercept, moves the graph up and down. So let's take a look at a couple of simple ones. Y equals, and we'll keep just x. We won't change anything except the up and down feature. The vertical changes, up and down, vertical. Those are the words you can use. So if I put plus 2, notice the line moves up 2 spaces on the graph. Simple enough. You've operated with y equals mx plus b before, and you know the b is the y-intercept, up and down. Simple. Alrighty, so let's go back to a different parent curve. This one, we'll clear out the lines the best we can, and we'll go to the parabola. So y equals x, then remember, shift 6, 2. There's your parent for the parabola. And my screen, a brilliant red. Now, if I want to move it up and down, simple. I hit the tab key. That moves me away from the exponent. Look again. Look where the blinking cursor is. It's away from the exponent and next to the x squared completely. If I put plus or minus, I'm going to move the whole curve up or down. Let's move it up 2 spaces by hitting plus 2, and there it is. So now I took the parent and lifted it. And this is similar to what you did with the line y equals mx plus b. Very similar. For the parabola, they don't use the letter b, they use a different letter in most textbooks. When I say they, publishers, authors use a different letter for the up and down. They use k. Doesn't matter really, but we'll stick with what's common. So for the parabola, it's x squared plus k. I'm going to back off and put minus 2, and notice the parent curve has moved down. So let me go back to the parent, type in a second one, and this is going to be a transformation, a vertical transformation, x shift 6, 2, and then tab to move away from the exponent, and I'll hit plus 2. Now in color you can see the transformation, the vertical transformation. Then I'll put a third one in, y equals x shift 6, 2. Don't stop there. To get away from the 2, you hit the tab key, and this time I'll hit like minus 3. Moved it down. 3 colors, transformations. The parent is the red one on my screen, the original. The green one, I lifted it up. Plus 2, k was equal to 2. On the third, purple, yeah, it looks like it's purple. I moved it down, k is negative 3. Simple transformations, vertical transformations. Then I'll do one more of these. That will be the absolute value. Y equals shift vertical. Look far right on your keyboard and you will see it, probably underneath the delete sign. Find it on the far right hand side, short vertical symbol. Put the X, include that symbol again. There is my parent absolute value. No surprise. If I want to lift it, I'm going to add something to the graph just the way it is. That is, it's y equals shift and then x back to that shift vertical. But now I'm going to lift it. So let me lift it plus 3. There it is. Same one. Moved it up. V shape. On my screen, it went from, looks like green to red. That's called k equal to 3. Instead of the B for the line, typically we call it K. Usually they, again, the publishers. So I'm going to go to y equals absolute value of x, absolute value symbol. This time I'm going to move it down. I'm going to move the original, the parent. That's the first one on the screen. It looks blue on my screen, so I'll put -4. There it is. There they are, transformations. These are the vertical transformations. All right? And I had said I was going to do one more, but let's do a fourth transformation of the cube. Y equals x shift 6, 3. There's my cube. And I'm going to do a second one now. And I'm going to lift it vertically. K is equal to 2. I want to lift the whole green curve that's on my screen by 2. So I keep the same function. I can copy it if I want, or I can just re-enter it. Y equals x shift 6, 3. But now, tab to move away from the exponent. Let's lift it. Let's lift it 3 spaces plus 3. There you are. It's the same curve. It looks a little different. That's because you've lifted it. But if I were to push them together, they would be congruent from your geometry. They would fit on top of each other. So you've got that different y-intercept, just like you do with a line. It went from 0 in the first one to 3. And I'll put another here. And this time we'll lower it. So it's y equals x shift 6, 3. Hit the tab to move away from the exponent. And I'm going to move the original one down 2 spaces. There you are. Those 3, if you were to cut them out and put them on top of each other, they would fit. They're congruent to each other. The only thing that's different is the vertical transformation, K. In the case of a line, we call it B, but vertical transformation, whatever you call it, up 3, down 2, and of course you can do anything else you wish with it. Now, I haven't changed anything else. This is strictly the vertical transformation. So going back quickly, just to review, any graph that you put can be lifted or lowered. Call it B for the line, call it K for the parabola, call it K for the cube, call it K for the absolute value graph. Whether it's K or B, it's a vertical transformation. All right, so let's call it a conclusion for this graph. So let's see, I'm going to stop